Hello students, in this video I am going to talk about method of mixture. Now what is method of mixture? See, basically this method of mixture is used to find out the specific heat capacity of a substance. We know that heat energy absorbed or released by the substance can be calculated by the formula Q is equal to mc delta T, where m is mass, c is specific heat capacity, and delta T is temperature difference. But the question is, how do we measure specific heat capacity? So for that we can use the method of mixture. As the name says, as the name suggests, method of mixture is a method in which two substances are mixed. Okay, two substances are mixed. Now out of these two substances, one is hot substance and another is cold substance. So when we mix these two substances, one hot, one cold, we are basically generating temperature difference. We are basically generating what? Temperature difference, which is essential for heat to flow, because we know that heat flows from hot substance to cold substance or from high temperature to low temperature. Alright, so because of the temperature difference, heat flows from hot substance to cold substance. And the process continues till both the substances are at the same temperature. Once both the substances are at the same temperature, heat does not flow, right? Because now there is no temperature difference. And this particular state, when both the substances are at the same temperature, is called, this state is called thermal equilibrium. That state is called thermal equilibrium. And the temperature, the temperature of the mixture and in this situation the temperature of mixture is known as the final temperature. The final temperature of mixture. Now let us understand this with the help of an example. Let us say we have a metal and specific heat capacity of this metal is unknown. Okay, we want to find out specific heat capacity of metal. So we will mix metal with water. Now, as I said earlier, we will keep one substance hot, so here we will keep metal as hot substance and we will take water as cold substance. Let us say temperature of metal is 78 degrees Celsius and initial temperature of water is 28 degrees Celsius. So when I drop metal in water, okay, when I drop metal in the water, metal is at high temperature, water is at low temperature. So here a temperature difference is created because of which heat flows from metal to water. Okay, heat flows from metal to water. So what happens is temperature of metal decreases and temperature of water increases. Alright, temperature of water increases and the process continues till metal and water both gain the same temperature. Alright, now one more thing guys here, that we know that metal is kept in water, but water cannot be in air. Okay, water must be kept in a container. So here the question is, now when metal loses the heat energy to the water, is it possible that whatever heat is lost by the metal is absorbed totally by water only? Is it possible that the container in which water and metal are kept, that container does not absorb any heat energy? Is it possible that the heat is not lost to the surrounding, to the environment? No, it is not possible. Some energy, whatever energy is released by the metal, out of that some energy is of course absorbed by the container in which water is kept. Some energy is lost to the surrounding also. But here we have to assume the ideal condition, and the ideal condition says that no heat is absorbed by the surrounding, okay, or no heat is lost to the surrounding. So in the ideal condition we say that heat lost by hot substance is absorbed by, or let me put it this way, heat lost by hot substance is equal to heat gained by cold substance, provided no heat is lost to the surrounding. Now this is very crucial point guys, right? No heat is lost to the surrounding. So this is the ideal situation. So whatever the heat is lost by the hot substance is completely absorbed by the cold substance. No heat is lost to the surrounding. Okay, here we are considering no heat loss. So this statement is called the principle of mixture. Alright, the principle of mixture. Now let us see the application by taking some values for metal. Right, we already know that metal has initial temperature 78 and water has initial temperature 27 degrees Celsius. So metal and water, initial temperature of metal is 78, initial temperature of water is 27, but we need information of masses as well. Okay, so mass of metal is 15 gram, mass of water is 50 gram. Specific heat capacity of metal we want to find out. Specific heat capacity of water is given 4.2 joule per gram degree Celsius. Even if it is not given, its value you are supposed to remember. And the final temperature of the mixture is also given 28 degree Celsius. Now see, how do we measure the final temperature of the mixture? See, we have water, we keep thermometer in water, and thermometer reads 27 degrees Celsius. Okay, thermometer reads 27 degrees Celsius. Now when we drop metal in water, metal loses the heat energy, water absorbs the heat energy. So on absorption of heat energy by water, mercury level in the thermometer rises, and we have to observe the rise in the thermometer, rise in the mercury level in thermometer. And after some times, when the final temperature is reached, okay, the mercury level also stops rising in the thermometer. So once the mercury level stops rising in the thermometer, that's the final point, that is the final stage, and we have to stop at that point. So that we can notice with the help of thermometer. So final temperature is 28 degree Celsius. Okay. Now you first need to write a statement that according to principle of calorimetry, sorry, let us write according to principle of mixture, heat lost is equal to heat gain. Now this is compulsory, guys. Okay, you must write this. MC delta T of hot is equal to MC delta T of cold. Let us put the values. 15 gram specific heat capacity we want to find out. Now delta T, 78 is the initial temperature, 28 is the final temperature. But we know that whenever we find delta T, we always write delta T such that it is bigger temperature minus smaller temperature. Mass of water 50 gram, specific heat capacity is 4.2 into delta T is 28 minus 27. So this becomes 15 into specific heat capacity into 50 is equal to 50 into 4.2 into 1. 50 and 50 cancel. So we get now specific heat capacity as 4.2 upon 15 or 42 upon 15 into 10, that is 14 upon 50, that is 28 upon 100. So specific heat capacity is 0.28 joule per gram degree Celsius. This is the answer of specific heat capacity of metal. Thank you.